Thanks. Every time you need to remind about recording, yeah. Thanks. Okay, class. So after kinematic, so today going to be dynamic. Dynamic is about Newton's law. So all about Newton's law. Again, it's about I can say 70% is something old stuff what you learned before. 30 is something new. Okay, so let's recall back what Newton done. Okay, so these are the learning outcome. You can read, but I just straight go to the Newton's law. Okay. So first thing you have to know about what Newton did is, of course, inertia. Okay. So inertia. So I believe everyone knew about inertia. Okay. So inertia. Do everyone have same inertia? Do everyone have same inertia?
Oh,
No. Inertia proportional to what?
mass.
Yeah. Inertia, is it opposes motion? Is it inertia opposes motion?
Yes, right.
Is it opposes motion? That means, is it don't like motion? It don't like motion, or it don't like changes in motion?
It changes.
It don't like changes in state of motion. Please be clear with that. It doesn't mean it don't like movement. It don't like changes in state of movement. If you are moving, make sure you're continuously moving. If you are not moving, make sure you are in rest. Okay, that's inertia. Inertia proportional to mass. Is it inertia affected by gravity? Is it inertia affected by gravity? No, inertia is nothing to do with gravity. Okay, so that's about inertia. So inertia is a tendency of an object to resist the change in its state of motion. Okay, so it don't like any changes to the motion. Okay, like the car when drive move forward, what happened? The person will lurch forward because of his inertia. Okay, the car stopped, but he will be moving more forward because of inertia. The larger the mass of the object, higher its inertia. Okay. So what is the definition for mass? What is the definition of mass? The amount of matter of the amount of substance of a matter. Okay, the amount of substance of a matter. But sometimes they call mass is what? Mass is like it's a measurement of inertia of a body. Okay, mass is a measurement of inertia of a body. Okay, so that is definition, new definition of mass. Okay, so so breaking the glass, breaking the egg is all like inertia. Okay, holding the knife, just drop the knife into the table vertically down. Okay, taking the sauce out of the bottle is because of the inertia of the sauce. Okay, you stop, move the bottle, but the inertia of the sauce will make it move forward. Okay, like book, you can remove the book at the bottom by moving fast, because other books inertia want to stay still, so that's why you can remove the book faster. Because this all inertia. Okay, a coin, you can move the coin from the, I mean, if you move the card very fast, the coin will fall into the glass because of inertia of the coin. Okay, the coin the inertia of the coin want it to be stay still. Okay? This all are example of inertia. Okay, Newton's law of motion. Recall back, you already learned these three. So what are the three Newton's law of motion? Okay, so Newton's law explains the motion of an object, forces acting on the object. I can go this very fast because you learned this before. Okay, so the forces on the book are balanced by the two forces. Okay, balance force explained by the Newton's law. Okay, the force acting in the book are not balanced. When you give an external force forward, it starts to accelerate. It's explained by the Newton's law. Okay, so balance force, unbalanced force. Okay. Okay, if you have a net force forward, then of course you start to accelerate. Okay. Okay. So straight to the point. The wall on the ball are in rest. Net force on the wall and the ball is 0. Okay. So these all are Newton's law. So acceleration force is double. The force become double. Okay. The force is balanced, so it will be in stationary. Okay. So these all are the produce the same as. So these all are. Okay. So we go to the law first. First, what is the Newton's first law say? An object will. So recall back. So an object tend to remain in state of motion unless a resultant force acts on it. Okay. An object will either stay in stationary or it will move with a constant velocity unless an external force is applied. Okay, this is indirectly explaining inertia, right? Okay, so that's about Newton's law. Okay, what is Newton's second law say? Anyone? Newton's second law? Force is directly proportional to the rate of changes of momentum. That's the Newton's second law. Newton's third law is what? Every action there is an equal opposite.
Equal opposite reaction.
Okay, okay. So that's the three things. Okay. So I believe you learn about linear momentum also. Linear momentum is what? It's a product of mass times velocity of an object. Okay, linear momentum. O level, do you learn linear momentum? O levels.
Huh?
O levels, do you learn about linear momentum? Momentum.
Yes.
Learn about linear momentum. So momentum is a product of mass times velocity. So vector or scalar? Momentum is a vector quantity. Okay. So, okay. So property of moving object. Linear momentum is a property of moving object. It's a vector quantity defined as product of mass and velocity. It's mass times velocity m times v. Okay. So when p is momentum, mass is velocity. Okay. So unit is kg and mass -1 Newton per second. Okay. I don't know why the animation is not. Okay. So first question, find the momentum of a particle of mass this traveling at this speed. So mass times velocity is going to be our momentum. So 1.32 times 10 power -19 kg ms -1 momentum. Calculate the momentum of the car of 1.5 tons traveling with a speed of 75 km/h. So what is the momentum of this car? So 1 ton, how many kilogram? 1 ton is 1,000 kilograms. So 1,500 times 75 km/h. 75 km/h, you change to meter per second, you get momentum in kg ms -1. Okay. So you should get 31250. 75 km/h change to meter per second, you just divide by 3.6. The number should get smaller. Okay, this is momentum. Okay, the first question, what's the answer?
Yes, if no air resistance.
No air resistance. If no force acting on a moving mass, you keep moving along the same path with the same velocity forever. Yeah, it's true if there is no air resistance, no external force. So true. Yeah. Okay. So which of the following object has the largest momentum? Okay. This just calculating the values. Okay. So you calculate mass times velocity, check which one got the highest. You can get the answer. It's not a big issue. Okay. So we just keep to the next part. Okay, change in momentum. When a tennis ball of 660 grams moving forward wall and speed at 10 meters per second, after colliding with the wall, the bounces with a speed of 5 meters per second. The ball is in contact with the wall for 3 milliseconds. Okay, so 10 bounces back 5. Okay, please get me the answer for this. 2 minutes for you. Determine the change in velocity for the ball. How much is the change in velocity of the ball? 5? 15?
15.
15. Should be 15, right? The change in momentum is 15. Okay. So of course, V final minus V initial is your change in momentum. So V final is to the left, we take it as negative. So if you put -5, so minus V initial is 10, positive 10. So you got -15. Okay. So the magnitude is 15. 15. Negative tells the direction change, is to the left. Okay. So you get 15. What is the average acceleration? So average acceleration is V minus U over T. So divide by 3 milliseconds, give you the acceleration, right? So you get 5,000 meter per second squared. Just divide by 3 milliseconds. Okay. Next question. What is the average force acting on the ball? So average force, anyone? So average force is mass times acceleration. You know the acceleration already, just multiply by the mass, 60 gram, change to kilogram. So you should get the average force. So it's about 300 Newton. Okay, so F equals to MA. A, you know, M, you know, 60 gram, change to kilogram. So you get 300 Newton. Okay, so next. What is the average change in momentum? Anyone?
V initial minus MV.
Yeah. So final momentum minus
MV.
MV minus MU, you get the average change in momentum. So you should get around 0.9 kg per meter per second. Okay, so 60 gram times 5 minus 60 gram times 10 should give you the changes in momentum. Okay, what is the rate of changes of momentum? Rate of changes of momentum is what? Changes in momentum divided by the time. So 0.9 divided by 3 milliseconds is your rate of changes of momentum. So what again? 0.9 divided by 3 milliseconds. So you should get 300 Newton. Okay. You should get 300, 0.9 divided by 3 milliseconds. Okay. Compare your answer in part 3 and part 5. What do you conclude comparing 3 and 5? So the force acting on the ball is equal to the rate of changes of momentum. A rate of changes in momentum is the same. This is Newton which law? Force is rate of changes. Second law. Force is directly proportional to the rate of changes of momentum. Okay. So this is what they are trying to proving. Okay, that's your Newton's second law. Can be stated as rate of changes of momentum is directly proportional to the resultant force. Okay. It is proper to say resultant force. Instead, you say force. Anyone say force is directly proportional to the rate of changes of momentum? Less likely correct. I prefer you to say that the resultant force. Okay, the net force or the resultant force is directly proportional to the rate of changes of momentum. Okay. Check with the previous slides question and the answers for the part 3 and 5. Okay, we already proved that. Okay, force, resultant force is the rate of changes of momentum. The earlier slide. Okay. Okay. So when a 50 kilogram person jump at 5 meter, at a height of 5 meter, the force F acting on his leg when he lands is change in momentum per unit time. And T is the time between the just before landing and after he completely stops. His speed just before hitting the ground is 9.9 meter per second, let's say. Okay, let the time taken for him to come to the rest to the ground is 0.1 second. Calculate the force that is exerted on him by the ground. How much is the force exerted by the ground on him? And just before land, his speed is 9.9. It took 0.1 seconds to come to rest. How much force acts on him? So what formula do you use? F equals to mv minus mu over t. Final momentum minus initial momentum over the time contact, you get the force. Which momentum is zero? Final zero or initial zero? Final is zero because it's top one. Initial momentum is how much? 9.9 times 50 kg. Okay, the time of collision is how much? 0.1 second. So you can find the force. Okay, the force should be 4,950 Newton. By using which formula? So because the force by the floor to the person is mv minus mu over t must come to your mind. So your v is 0, your u is of course but 50 times 9.9, and your time should be how much? 0.1 second. You should be able to get this force. This is the force experienced by the person. Rate of changes of momentum is the net force. Okay. Okay, there is a. If someone asks when to put a negative sign, when not to, for the force, is it? For the, when they say ask for changes, you don't need to put negative. Okay, if they ask for changes, you don't need to put negative. But if, so changes don't need to put negative. Just take it as positive. Okay. You mean changes for what? Velocity, momentum, is it? Okay. For the case of force, also you can leave it as positive when they ask for the forces. Okay. If he bends his leg, increases stopping time to 1 second, what is the force acting on him? So of course, when the time of collision rises, the force exerted on him is shorter, right? When time of collision rises, the force exerted on you is smaller. Okay, that's what adapted by all the safety features in the car. Your airbag, your seat belt, all are safety features because of what? It tried to increase the time of collision so that the force exerted on you is smaller. So here 1 second greater. Last time was 0.1 second. Now 1 second. So force become 495 Newton. Tremendously small. Okay, another one question. 1 minute. Give me the answer for this. What is the rebound speed just after impact? A ball of 0.2 kg is dropped from a height of 3.2 meters onto a flat surface. It hits at 8 meters per second. It rebounds to 1.8 meter. So what is the rebound speed just after impact? Anyone? So they're asking what is the rebound speed. When you take off, what is the speed? But after rebound, you're able to rise height of how much? You're able to rise the height of 1.8 meter. Okay, so what is the rebound speed? This one, I think you can use conservation of energy, right? You can use the conservation of energy. The kinetic energy at the bottom tend to become potential energy at the top. So I think mgh should be equivalent to what? Half mv squared can give you the velocity, right? So yeah, mass cancels, so you can find the v. So what is the v you get? 2gh, square of 2gh. So that should be the answer here. So 2 times gravity, 9.81 times h. H is 1.8. We'll get the speed here, the rebound speed. So anyone got the answer? So you should get 5.94 meter per second. Okay. So how do you find the speed? Conservation of energy. Potential energy gain is the same as kinetic energy at the bottom after rebounds. Okay. Okay, next. Get me the answer for this. Okay, let me rub this. What is the change in momentum of the ball between just touching the surface and leaving it?
Teacher, for that calculation, the
Yeah.
acceleration should be 9.81 or negative 9.81.
Okay.
Because if I put negative and then the cert and then it can't work.
You see, gravity negative 9.81 or positive 9.81. The sign consideration only done for the topic of kinematic.
Oh, okay.
Okay, when come to other topics, we just want the magnitude. For gravity, we just take 9.81. Okay, so therefore here I just put 9.81. Okay, force is all like 9.81. So what is the change in momentum of the ball between just touching the surface and leaving it? What is the change in momentum? How do you find change in momentum? So the force, mass is given, rebound speed, you know, they want change in momentum. So yeah, so what formula use? Changes in momentum is, of course, the final momentum minus the initial momentum. So final momentum is what? MB minus MU, you'll get the answer. So mass we know, V is, V we have to be careful. V is going up, right? So going up, so first he hit the ground with 8, should be, then he going up 5.94. So because the two direction involved, so down we take -8, up we take positive 5.94. Sorry, yeah, we take upwards as positive, okay. So V will be 5.94 minus 8, okay. So you get changes in momentum. Eventually, the velocity will be added. Anything bounces, going down and going up, the final and initial velocity, the magnitude will become bigger. It will be added. Okay. So therefore, you get a momentum loss. So mass is 0.2. So what's the momentum you got? The changes in momentum. So you should get 2.79 newtons NS or kg ms -1. The changes in momentum. Okay. The body experienced 2.79 newtons. Yes. Okay. So you should get here 2.78. Okay, next. Say duration of collision is 0.02 seconds. Calculate the force acting on the ball. So changes in momentum divided by the time will give you the force. Force is what? Rate of changes of momentum. So changes of momentum divided by the time give you the force. So 2.79 divided by 0.02, you will get the force. So here you should get around 140 Newton and the force acting upwards from the ground. Correct? Because the object, when you collide, the object will experience a force upward or downward. The object will experience a force, the ball will experience a force upward. So the 140 Newton is a force experienced by the ball upwards. Okay, upwards from the ground. Okay, any problem from this question? Okay, so what we are trying to emphasize here is force is rate of changes of momentum. Okay, so MB minus MU of T is your net force. Okay, that's what we are trying to emphasize here. Okay. Okay, so that's your Newton's second law. Force is rate of changes of momentum, and the changes occurs to the direction of force. Okay, I want to add here something about Newton's third law. Okay, let me go to the whiteboard. Okay. Okay, class. You see here a hose. There is a hose. Water is come out from the hose with 50 meter per second. The water is come out from the hose with 50 meter per second. Okay, and the amount of mass of water comes out from the hose. Okay, mass per unit time. The mass comes out per unit time. from the hose is 2 kg per second. Okay, this water go and strike to a wall. There is a wall. Okay, there is a wall. So it strikes the wall. Okay, it go and strikes the wall. Okay, so the water definitely going to exert a force to the wall. The question is, how much is the force exerted by the water on the wall? How much is the force exerted by the water on the wall? Okay, so this is a very unusual question. I give you 1 minute for you. Can you give a try? The mass comes out from the tube is, the mass per unit time is 2 kilogram of water comes out from the tube in a second. The speed the water comes out is 50 meter per second. I'm asking, what is the force the water will exert to the wall when it strikes? Okay, how we going to do this? This is, we know only F equals to ma, F equals to ma. Okay, F equals to ma. So, oh, sorry, I made a mistake. Not to the wall. Sorry, it's not a mistake. Let's say a person, like a person holding the hose. A person is holding the hose. Okay, when the water move forward, the person will experience a force backward, right? Will experience a force backward, right? It's action reaction. So the question is, sorry, not the force on the wall. What is the force exerted by the person when he move backward? What is the force? That's the force I want. Okay. So how do you find this force? Okay. Force, what Newton said. Force is rate of changes of momentum. Okay, this is going to be a little mathematical. Okay. dP over dt. That is what wrote by Newton. Okay. This is what Newton wrote when he explained his Newton's law. What is P? P is momentum. Okay, P is momentum. Okay, MV. Okay, because Newton is a godfather of calculus. He's the one invented calculus. Your differentiation, integration, all from him. Okay, so he wrote all the force formula in the differentiation form. Okay, now F equals to D, but mass momentum is what? Is mv dt. Okay, mv dt. Okay, so now it's a little of differentiation. Anyone never learned differentiation before here? You can't understand what I'm going to do now. Anyone didn't do differentiation here? Anyone didn't take additional maths in your early studies? Then I think you might have a problem here. Those who have differentiation, you can understand this. Why I'm deriving this? Just to do this question. Okay. So you see here, this is m and b. When you differentiate m and b, like last time, you got y equals to uv. You want to differentiate dy dx. How do you differentiate it? You do dv dx. Then anything? What do you do? Plus v du dx, right?
Oh yeah, that.
Right. This is the what do you call differentiation, right? When you got 2u and v. Okay, same thing we're going to add up here. Your m and b like u and v now. So how do you do differentiate now in terms of t? So m, put it out. It's going to be dv dt. Okay. Then plus with, now you differentiate what? You put the v out. Differentiate the mass dm dt. Okay. So this is the differentiation, because Newton said force is rate of changes of momentum. So momentum is mv. So differentiation must form m first and later v, like in this formula u and uv. Okay, now let's simplify this. So f equals to m. dv dt is what? Anyone?
VDT.
dv dt. dv dt, rate of changes of velocity, what? V, right? Rate of changes of velocity is what? Anyone?
Acceleration.
Yes, it's acceleration. F equals to ma. Okay. Okay, now last time you only know F equals to ma, but in reality there is something else which is still alive at the back. V dm dt. This is the actual force formula by Newton, you know. This is the actual force formula by Newton. Not F equals to ma only. It's F equals to ma plus V dm over dt.
Then why is the neglected?
Why it was neglected? Why it was neglected? You see, when you have a car, you move. When the car move forward, okay, with an acceleration, is the car experience any changes in mass or not?
No.
Mass never change. So normally the mass, the rate of changes of mass will become zero. So therefore the V dm dt becomes zero. Normally. Normally. So F only equals to ma. Okay. But question like this, the mass per unit time is alive. You see, mass per unit time 2 kg per second is actually dm dt value, you know. Dm dt value. So question like a hose, water comes out from a hose. Like a rocket, the fuel comes out from the rocket. How much is the force exerted by the fuel? It has a mass per unit time of fuel comes out. And for that, how much force you need to calculate? For this fuel, do it as acceleration. It don't have acceleration. It's just mass per unit time. It comes out with a constant speed, you know, constant speed. So acceleration become zero. So for this question, the force formula would be what? Only V dm dt. Only going to be V dm dt. ma not alive this time. Okay. So what is the force exerted by the water to the person who are holding the hose is 50. The V, the speed of the water comes out. The mass per unit time of the fuel comes out, the water comes out. It's 2. So it's about 100 Newton should be experienced by the person. This is how you calculate the force, and mass per unit time is involved.
Why is MA not included?
Because the water does not accelerate. Is it the water when it comes out? Is it accelerating? It just comes out with a constant speed. Okay. Okay. So this is something new for you. Notice it's something new which never revealed last time. You are trained with F equals to ma because 99.9 cases of moving object, it doesn't experience changes in mass per unit time. But when it comes to fuel, like a rocket, as I told you, fuel or water comes up from a hose, it do exert force. How do you calculate the force? V dm dt. Okay, V dm dt. That's why in your A level, is it proper to say force is mass times acceleration?
No.
Is it proper to define force is mass times acceleration? No, right? If you say F equals to ma, that means you are neglecting V dm dt. So what is the proper way explaining force? Newton's second law. Force is what? Rate of changes of momentum. This is the best definition. If you say rate of changes of momentum, the entire thing is covered. Okay. Understand any question from this part? Okay, I got some chat some questions. Okay, so acceleration. Yeah. Okay. So any question from this part? So remember, any question they're asking force and they give mass per unit time with kilogram per second or gram per minute, anything like a mass per unit time, that means the force formula you must think about is V dm over dt. Okay, V dm over dt. V velocity times rate of changes of mass will give you the force. Ma is useless in these cases. Okay, so when acceleration alive, dm dt won't be there. And dm dt is there, A will be 0. So any one of the equation will be live. Yeah. Yes.
Since we are talking about the man going backwards, so then should the answer be negative since it's the opposite direction?
Yeah, good. The force, we are just calculating the magnitude of the force. and the direction should, you must say to the opposite direction. Yeah. Because it's action reaction path. Okay. So you got the idea. So this is the new idea. Please remember this. Okay. So let me go back to the slide. Okay. So that's about Newton's second law. Okay, Newton's second law. So let's go to Newton's third law. So what is Newton's third law says? Everyone knows action, reaction, path. So when a body A exerts a force on body B, the body B will exert the equivalent magnitude of the force on the body A. Okay. The fuel exerts a force downwards. Therefore, the rocket will experience a force upwards. Okay. So tire pushes on the road. The reaction is road pushes on tire. It's action, reaction path. Okay. The action is the rocket pushes on the gas. The reaction is gas pushes on the rocket. Okay. So action, reaction path. Rocket pushes on the gas pushes the rocket. Okay. Okay, this is a very weird one, not to say weird one. The earth pulls on ball. That's the action. The reaction is ball pulls on earth. Okay, another word. Earth pulls you. Action. Earth pulls you. Action. What is the reaction? Earth pulls you. It's action. What is the reaction? You pull the earth. Okay, you pull the earth. That's the reaction. Okay, so maybe you feel it sounds funny, but that's the truth. You see, this is earth, so huge. You are here. Okay, let's say you are falling down. Let's say, according to Newton, earth is pulls you. No doubt about that. Okay, according to Newton, you also pulls the earth. Two mass objects, according to Newton, will have an attractive force to each other. Okay,
Yeah, very
they are
small.
pulling each other. They are pulling each other. So earth pulls you. Action. The reaction is you pull the earth. Okay, but now the question is, you don't see that earth come towards you. You don't see earth come towards you. Look like you are the one going move towards the earth. Anyone can explain this? Why?
Because every mass has gravity.
You see, the force experienced by you caused by the earth. Okay, this is the force by you experienced by you. One. This is cause experienced by the force experienced by the earth. Okay, the earth. This is by you. I put one. The person. This force experienced by the earth. The force is same. The magnitude is the same. Okay. Your force is your mass times the gravity. Okay, that's the force. But what is the mass of the earth? Mass of the earth is so huge. So the acceleration of the earth will be very
Small.
very small. It might be close to zero. So the force do experience force caused by you, but because the earth is so massive, we can't see it moving towards you because the acceleration is too small. But we can't neglect you are exerting force to the earth. But the earth pulls you, action. The reaction is you pull the earth. Okay, that's the reaction. This is Newton's third law. Okay, so remember these three points which never realized. Two pairs we see to be action reaction pair. The two pairs, the two forces must be same magnitude. Of course, they must be same magnitude. Okay, if different magnitude, they are not action reaction pair. Second, the both force must be same type. The both force must be same type. Same type means if the action is gravitational force, the reaction also must be gravitational force. If action is the electric force due to electric field, the reaction also must be electric field. Okay, the action is a magnetic force, reaction also must be magnetic force. It must be the same type. And the third feature for action reaction pair, which not many people realize this, is the both force must act on the same body or different body. The action and reaction must act on the same body or different body.
Same.
Must be the same body. You see, earth pulls you. That's the action. Acts on who? On the earth or on you? Earth pulls you. It's action. Act on you or on the earth? Earth pulls you. Act on you, right? So the force is act on you. The action is on you. Earth pulls you. Okay. So the reaction, you pull the earth. Reaction is on which body? To the earth. Okay. So action reaction pair both must act on different body. They must act on different body. If the force act on the same body, if the both force acting on the same body, they are not action reaction pair. Okay, this three is very important. Okay, if you want to categorize action reaction pair, they must be same magnitude, they must be same type, they must act on different body. Okay, so let's see how well you understand these three features. Okay, now I'm going to ask one question. Tell me. The question is this. Okay, go to the whiteboard. I clear this. Okay, tell me. An object was placed on the ground. What are the force acting on the object? The weight acting down. Any other force acting on the object? The normal force acting upwards, right? Is the weight and normal force action reaction pair? Put it in the chat. I want to see how many of you say correct, how many say it's wrong. Please think the three character I told you earlier. Is it weight and reaction force action reaction pair? Put it in the chat. Is it an action reaction pair?
Net force.
No. Is it the weight and the normal force? Is it action reaction pair? We can categorize based on Newton's third law. So I got three answers. Okay, so it's so I think out of four answers I received, three of you saying is yes, it's action reaction pair. One said no. Okay, I need more answers. Come on. Is it weight and reaction force? Is it an action reaction pair? Do it as the three feature. Is it same type? Is it acting on a different body? Is it same magnitude? Okay, if these three same, then we say it is an action reaction pair. Okay. Okay, I think many saying yes. Okay, only two of you saying no. So I'm saying is, of course, it's no. They are not action reaction pair. They are not. Why? It's a wrong concept. You did it. Why it's not an action reaction pair? First reason is both force acting on the same body or different body. Weight acting in which body? On the object, right? Let's say you stand here. If you stand here, okay. Weight acting on you, right? Weight is the one pulling you down. So weight is acting on you, right? The reaction force acting on you on the floor. The reaction, the normal reaction. Is it acting on you on the floor? You react what? When you press the floor pushes you up, right?
Yeah.
The floor pushes you up, So reaction is on you or on the floor? On you, what? The floor pushes you up. So it push you up. So you experience the push. So the normal force and the weight is acting on the same body. So the first character is wrong. Both force acting on the same body. So it's not an action reaction pair. The first rule is out. Okay, they're acting on the same body. They're acting on the same body. Okay, another one rule is it weight and reaction force always the same? Is it if let's say the weight is 800 Newton, is it the reaction force going to be 800 Newton? Can reaction force can be different than weight? Can anyone?
Yeah.
Can normal force different than the weight?
Yes.
Yes. In which situation it can be different from the weight? When
Yes.
you travel in a what? In an elevator, in a lift.
With
When you stand in the lift, as a lift accelerate upwards. The weight is acting down, mg. You get a normal force up, Fn. Okay, tell me, in this situation, the mg and the normal, is it same or different? Same or different? The elevator is accelerating up.
different.
Different, right? So, what equals to ma here for this elevator? If it accelerates up minus force down. So, Fn minus mg will be your ma. Okay, if accelerate up minus force down. If accelerate down, force down minus force up. So accelerate up, force up is bigger, so Fn minus mg is ma. Okay, so Fn and mg is not same. Fn is looks like bigger than mg. Okay, so Fn, its second factor is a failure. Fn and mg is not same magnitude always. They can be different magnitude. Therefore, they are not action reaction pair. Very common asked in A levels. They'll ask weight and reaction force. Is it an action reaction pair? The answer is no. Why? Because both force acting on the same body. Second, their magnitude not necessarily always the same. In elevator, if they accelerate, the normal force get bigger. If accelerates down, the normal force gets smaller than weight. Therefore, they are not action reaction pair. Okay, that's the reason. Okay, so those who said yes, okay, those who said yes, you need to think back. Okay, so because after Form 5, I think when you come to A levels, you realize this. So, what are the three factors to categorize them as an action reaction pair? First is what? Both force must have same what? Same magnitude. Whatever situation, they must have same magnitude. Okay. Second, they must have what? The both force must be same. Same type. Both of them must be same type. Okay. Third, most important, both force must act on a different body. Okay. They must act on a different body. Then it's an action reaction pair. Okay. So any questions for today? Just introduction of Newton's law. Some new things you learn is the second law, F, rate of changes of momentum, is proper to define it as dp over dt. Don't call it F equals to ma again. Okay. Sometimes the A level mark scheme, they accept the answer. Sometimes they don't. So to be safe side, right, force is rate of changes of momentum. Okay. An action reaction pair, weight and normal force is not an action reaction pair because they can have a different magnitude. They definitely act on the same body. So they are not an action reaction pair. Okay. So these are the two stuff you learn, something new. Other than that, it's same. Okay, any question? Okay, no questions. Okay, class. So we're going to stop the end the class now. I want you to read more about this Newton's law. So the next class, we're going to do more questions about Newton's law. What we're going to do is the application of Newton's law is about case of pulley. You know, in a pulley, how the mass are moving down and going up. We're going to talk about elevator. In the elevator, and the object moving up and down, how's the net force, normal force changing. Third, we're going to talk about object moving in an inclined surface. Okay, these are the three applications of Newton's law. we're going to discuss tomorrow. Okay. So any questions? No questions, eh? Okay, so if you don't have questions, I'll wrap up here. Try to think about the Newton's law. Eh? So the next class, we're going to discuss about the application. All the pulley, everything in the slide, you can read through, get ready. Okay. Okay, so that's all. Thank you.